All right, welcome everybody to the Coding with Callie meetup. Mao, when you are ready to get started, you can just kind of take it away. Oh, are
Cool.
you good with questions during your presentation, or do you want people to wait until the end?
No, I'm fine. Actually, that's part of the presentation. So I'm fine with people just asking questions. This is a discussion. This is yeah.
Nice.
So
I love your logo. It's beautiful.
it is beautiful, right? You like it?
Yes, I'm
I
very
like
excited for your talk, by the way. I've been like pumped for it.
Yeah, so I like raccoons more, but I guess this is not too bad. That's
He's
lot. So
raccoon adjacent.
yeah. So yeah, so hi everyone. I'm super happy to be here. Mm, This is supposed to be a technical presentation, but this is the first time that I do this. We talked before, Callie and you and me, about like certain topics, and we came about talking about monoliths and microservices. So if it's like too high level, maybe you can let me know, and we can just go for more deep concepts. And if there are like a lot of concepts that I'm just throwing there, we can review them. So just ask me, and yeah, just ask me any questions, interrupt me. So why you should believe me? You should not. I mean, challenge me all the way, like question everything, ask for clarification. We are here for discuss. But why you should listen to me? So I have some experience doing software development. I fail a lot. I have done a lot of software or develop a lot of software, and a lot of times I did the not the right thing, right? But I love to learn. Like from each failure, I love to learn, and you're already here, so why not, right? I work at Microsoft, which honestly, I mean, it is like working in any other company, but I guess now we are cool. Like a few years ago, we were not cool, but now we are. So I guess I will just throw it there. Um, yeah. So to the thing. So what is a monolith? A monolith is just like a single code base, like a single application. It's a self-contained application that runs. Most of the time when we are writing software or applications, we start as a monolith, right? This is not written in stone. Like remember that all the concepts in software development are always like not always black and white. So like this meant to be disrupted, but most of the time monoliths are just that, a single system. It can be huge, it can be small, medium, I mean, it doesn't matter. It can have multiple databases or multiple services. The code can be split in different repos, and at the end of the day, everything is deployed as a single thing. So there is a single point of entry for that. It can be either a front end or an API. And remember, an API, it's just a concept. So even if we talk a lot about web development, these concepts does not apply only to web development. Like it is where it is mostly used, but there are some times that, like this, the monolith and microservices can apply to things that doesn't have like a web interface, but it has other kind of interfaces. We also talk about a lot about REST APIs, but this talk and all the concepts also apply to sub APIs or GraphQL APIs or other kind of APIs. It doesn't need to be REST, but I mean, most of the time it's going to be a web development and a REST API. So does someone here has heard about microservices? Yes. Okay, cool. So like a microservice, it's by definition what is not a monolith, right? Like it is very difficult to define a microservices if you don't have a monolith. And a microservice, I mean, all of these you can go to the internet and just search for that and learn about that. I don't want to go there with definitions, so I came here with examples of things that I did in the past that were a monolith or were a microservice. But basically, microservices is a small independent services working independently from another, but at the end of the day, they have like a common goal to be able to deliver a service. Is
So
that
if I were to say that a monolith, you couldn't have any of the if a monolith is split into different repos, it's a monolith because they're all dependent on each other and none of them can work alone. and then microservices can work alone, or would that not be a correct statement?
Yeah, so I think the word here is self-contained application. So at the end of the day, if you deploy a monolith, you usually deploy like a one container or one cloud service, or you have one server that is running that. Like the server can be virtual or physical or whatever, but it's a self-contained application. So all the code, it does not mean that you don't have libraries. It does not mean that it is like it cannot be split in different modules or packages or whatever. So you usually have different repos. But at the end of the day, when you deploy this thing, it's one thing. It is very cohesive. Did I
Well, so
explain
then
myself?
I've only ever worked with microservices then.
Oh, that's interesting.
Yeah,
Oh,
I've never
wow.
just deployed one container. It's always like many containers.
What about I haven't seen the challenges, but what about the challenges that you have in the workshop? Are they monolith or microservice?
Well, I've always viewed it as monolith because it's like one repo. But if the definition is one container, we would have like a front end container communicating back end container.
Well, yeah, I mean, again, these are concepts, right? Like
Yeah.
it's very difficult to, at the end of the day, put it, but I will say that the front end is one monolith and the back end is another monolith. So we are gonna see, it's gonna be a little bit clear with examples, but yeah.
Okay, thank you. Yes, I always ask questions when something's a little bit fuzzy in terms of definition in my
It's
brain.
okay, yeah.
I've heard it defined previously as like self-contained, to where if one goes down, then it doesn't affect the other one. Is that accurate?
It is one of the big things about microservices and the pros, and we are gonna see this later. But yeah, I mean, there is on a monolith, you can tell that it's a single point of failure, right? You get the backend down, everything goes down. In a microservices, doesn't work that way. The backend is split between different services, so if something gets down, usually the application doesn't get down. If we are talking about authentication, right? So that's a microservice that is super important, and everything's gonna get down, or not, it's not gonna work even if you can still access something. So if you think like the e-commerce Amazon, right? So you go there and you have different services like the shopping cart, and you have the payment system, and all of that can be microservices. But also it can be just one huge application. I don't know. Did I explain myself? Cool. So the first case of a study. So long time ago, I'm talking about more than 10 years ago, I was working for a small startup in Mexico, and we were doing web development for different companies. One of those companies was Arrendamas. So Arrendamas is like the translation is like a loan plus, something like that. So this is like a small bank that was in Mexico. Like if you compare that with United States, maybe it's like a union bank or maybe a regional bank. So they were focused in giving loans. So we created a system that was made in Linux, Apache, MySQL, and PHP. It was a thing at the time. I know that it's not longer the thing. And this is actually when they went to the stock market. So this is the system that we have in Arendama. So it was divided in different parts, but one of them was CRM. I'm not going to talk a lot about that, but it's customer relationships management. It's just like having all the information from the people, and then you call and just follow up by leads and stuff like that. And then you have the ERP. So when someone requested a new loan, so it managed all the documents, the printing, the approvals, all the workflow of the application lifecycle. And then we have a payment system. So whenever the approval gets to approve and release the money, then when people was paying, we were managing the payment system of all of that. So the ERP and the payment system, let me see if I can, yeah. So these two calculated something that is called an amortization schedule, amortization table. So you know those tables where you have rows like interest and principal, and then your monthly payment and all of that. So we have
posted on my refrigerator.
Sorry?
I used to print out my schedule and have it for my house loan on my refrigerator.
Yeah, so that table, when you ask for a loan for I don't know, a mortgage or a car or whatever, that's the table that gets printed. So it gets printed as a quote here whenever we requested like the application. And then it was part of the system, of the payment system each time that someone like paid. You can do like advanced payment, right, to principal, and then you need to recalculate off of that. So it was actually when I came here to the system, because I didn't build this system by scratch, it was code in 7 different parts. Like this code was 7 different parts, and then we unified that and created one single library that was shared between these 2 systems. So this is all like a monolith. So this was all working like together. So we have this library that was shared between all of that. And then the customer wanted to create a web portal, like a public web portal for people to just go there and customers just go there and start the application. It added certain complexity and security and networking and stuff, but it was obvious that we needed just to add a new web page and then reusing the same code that we are using here, right? So that was fast. So this was a small startup. We were like not more than 10 people working there, and we were working with probably 5 to 10 projects at the time, like at the same time. So this was just one of those projects. Anyway, so we released the portal and everything was good. And then like everything exploded, like the company really went to the stock market and started getting more money, and they wanted more features all the time. And I was the lead developer there, but the rate of improvements and the features just exploded. So we couldn't handle all of that. And then we start hiring more people, more juniors engineers, and we are having like a good time with all of that. But around 2010, there was a big change on the tax rates on the Mexican IRS. And so I worked like, I think it was New Year's Eve, just to make sure that everything was like put in place for January 1st to release the new tax rate. So we hired a lot of people, but then it was mayhem. Like every time that someone new to the code base was trying to do something else, and injected a bug, it was like impacting everything. It was impacting the ERP, the payment system, the web portal. So releasing to production, it was painful. Like we have automated tests, QA, regression, CI/CD, but still it was painful. Like it really, like we were injecting like things to the system, bugs to the system. We were releasing stuff maybe several times a day. Then we did code freeze. We tried everything, but it added like trust with the customer because everything was interconnected. So small changes in the portal impacted the ERP and impacted the payment systems. So this is a monolith. This is a single cohesive piece of code, easy to develop, easy to deploy, easy to modify, but it's very hard to limit impact when something bad happens. Let's say that one of the pros of Thing is that it can be easy to understand and manage in smaller teams. But this is like a double-edged sword once the application starts to growing. So the functionality is like highly coupled. Any updates require a full deployment of the entire system. There is increasing risk of the bugs and downtime. Imagine, I mean, if you injected a bug that get the system down, everything was down, right? So in a monolith architecture also can lead to scalability issues. So that was what we found. So people like the IRP and the payment systems and the CRM, maybe we have 5 simultaneous users at the time. There was not much users, 5 to 10. But then the customers using the web portal, we were to the 100. Like there were some days that we have thousands of users just going to the portal and requesting a quote. And all of this, it was deployed in a computer in a customer office. But even when we migrated that to an actual server or to the cloud, you can imagine that you cannot scale just certain parts of the application. And we did
all one container. You have to have,
yes. So we optimized response times. We did aggressive caching in the portal. We did static web pages, but still there was a point, or there is a limit when you require to upgrade the hardware or something to scale vertically, right? You cannot scale, like you need to scale the whole system. So that is one of the disadvantages of the monolith.
But if you separate the web portal, you could scale the web portal.
Yes, exactly. Yeah.
Okay, but then the other 3, you can keep low amounts of those because there's only 5 people using them.
Yes. Remember, we were less than 10 people. I mean, it was not that we were smart, but we didn't have the resources. So we couldn't afford to rewrite a whole API, right? To communicate this and the other. So we actually, how we solve it is we ended up deploying the system twice. So we have 2 servers with the exact same code. Just one was a bulky server and the other one was not that bulky. So we ended up deploying the code twice. So imagine, I mean, you have this huge code base deployed to a server and then to another one. So that's where microservices could alleviate that. Like in contrast with Monolith, microservices can be break down in small, looser couple services, each one of them with a specific functionality. And we are talking about, that was an issue with the scalability, with the web portal and the RRP and whatever. But I mean, even these ones, I can see clearly that we can separate as different microservices. Was that helpful?
That was super helpful for me. Anybody have any questions? And we also do have a question in the chat too.
Sorry, I don't see it.
Okay. I missed it. It was a while ago.
Okay.
Oh, it wasn't really a question. It was more just just a statement, or at least from my perspective when I first started learning how to do it. Sorry, my voice is a bit scratchy today.
It's okay. I'm trying to navigate on Zoom. I don't know how to see it.
Guys, I would have assumed most people will start out with monoliths when they first start learning how to make a web app.
I see. Okay. Okay. Yeah. Okay. Yeah. Oh, that was for you. Like, yeah, sure. A microservice architecture is more complex, so most people start with monolith. Yeah, it's even good. Yeah, that's true. I mean, again, this is resources. Like you need resources to be able to go to microservices. If you don't have enough resources, and we are talking about people, but also about money and servers and everything, monolith is cheaper. Like you just create something and you just like pack it and then you just deploy it. We're gonna talk about some of the things about microservices that are also not that cool. Anyway, so what else? Yeah, so that's basically it with the monolith system. So if not for the questions, let's go with the microservices one. So time later, and then I joined a company that we were doing background check systems. So it was like a software that does background check systems. And this was also a monolith. So it was a big, huge system, like more bigger than the other one that we are talking about, because this was like something that was, I don't know, maybe hundreds of people have been working on that. So this system managed everything from, I don't know, like from the portal, from billing, reports, the actual background check system, sending emails, like everything was there, right? And then again, we had the same issues. So there was an architect, and I was architect at the time, but there was the chief architect decided to go to microservices. So we start like trying to think about how to split the system in different microservices. So we started like splitting in authentication was one, another one was document management, and this system also we wanted to migrate to the cloud. So it was a nice moment to do everything at the same time, like doing microservices, but also migrate to the cloud. And then, I don't know, you have different parts of the system that were broken into microservices. There was a lot of meetings about how to do this and design thinking and stuff like that. But then it starts like appearing a lot of microservices to actually build this thing. So if you think on this as, for example, OOP, right? Once that you start digging deep into abstraction, everything, at the end, you ended up like everything is an object. And the whole inheritance tree can get very crazy. So this is like over-optimizing for reuse. So when you are doing microservices, sometimes you get to that side. You get to the side that, oh, this can be a self-contained application and you start creating a microservices, right? Or when you do a database normalization, if you go like hard in normalization, you might end up with a lot of many-to-many tables or very excessive small tables. And that adds complexity to the system. Like it can be slow, it can be difficult to manage. So that is what happened when you go there. And that was what happened in this background check company. So we
notice with like speed of requests, since like in a monolith, right, you're just communicating within your code, but like here you have to send each one has to send the request to each other. So did that slow down a lot of the requests or no?
Yes. So there is some time, there is some bandwidth that you need between communication between microservices. Yes, totally. So you want them, you start planning like, oh, should this be closer to this one, right? Or if you are in networking, like, should this be in the same, I don't know, VPC or in the same region if you deploy to AWS or Azure, because they sometimes communicate. And then you start having things like, oh, this microservice is really used across the whole system. So I need to have replicas of this microservice in different regions in my cloud, right? And then you start having, oh, this microservice is only a reports and it's only used by the executives in the United States. So I just need one container in the United States. So you start getting that because yes, it adds time of communication between them. Yes, you totally. So, I mean, we ended up with dozens or hundreds of microservices on paper. This is before implementing that. Okay. And we start implementing some of them. One cool thing about microservices is that this system, again, was PHP. But when we decided to do microservices, we decided to do in C#. But one cool thing is that there is no rule to say that all of them should be in the same language. So you can have one microservice in C# and another one in Node.js or TypeScript and another one in Python. And that's fine. I mean, it works. They just need to have a common interface, and that's super important to communicate with each other. They can be working different teams. So there is one team that just do documents management, another one that just works in the reports one or in the authentication one. So that also is cool. You have a common API gateway. So I have seen that. So if you have front end or multiple front ends, sometimes you have a common API or one or two APIs gateways that just summarize or like make sure that it's consistent how you should show the APIs to the world.
So everything communicates to the API gateway before communicating to a different microservice?
I mean, it's up to you, but if we are talking about, you have the front end on Amazon and usually like the e-commerce, right? And usually you can see that there are 2 or 3 front ends. You have like the main one to search for products, but then once that you go to the payment, like the checkout, you can see that there is actually like a different front end. It feels like a different team was working on that. There is a different look and feel. So imagine that you have just 2. I'm sure that there are many. But then when you are requesting, let's say, like a shopping cart, right? Like the shopping cart of the people, you just go to /API/shopping cart. And that is your gateway, but that maybe communicates with a microservice in the back. So I'm pretty familiar with the API gateway that is on Azure. There is a service that is called like that, API gateway. But in Kubernetes, if it is familiar to like an nginx load balancer or like a proxy, where you have something that redirects to different pods inside the Kubernetes.
Okay, so it's not necessarily its own like code base. It's just like a list of, it could be just a list of rules of like where.
Exactly, it's a router. So you have in Kubernetes, you have that. I think it's a proxy, and then that goes directly to the service inside. Actually, in Kubernetes, there is the concept of service mesh, right? You can have that, and it gets as complex as this.
Yes.
But yeah.
Question in the chat. Johnny wants to know, with microservices, is it more is it more costly if you're hosting your own resources on the cloud, or is the cost on par if you were hosting a whole monolith on the cloud? Johnny, you might have to explain your question. I think
Yeah, definitely. So I guess I'm curious, like if we're comparing microservices with monolith, and let's say we have a monolith and we break that down into smaller services. Are we still paying the same thing in terms of like AWS resources or Azure resources? I guess my thinking was that if you break it down, it might be cheaper, or because it's a monolith.
So
Yeah, go ahead.
I am in a part of my life that I am super annoying because everything will be answered with depends.
Yeah.
So it depends. I mean, but I would say that most of the time it's more expensive because just the API gateway is another service that is running independently. And even if you don't have that, just having different services is going to be more costly. But again, it depends, because if we go to the bank system where you have a monolith and you needed to scale the whole thing to be able to manage the demand of the users, probably if you migrate that to microservices, it's going to be cheaper because you just need to scale one service, right? And then if you have auto scaling, probably it's going to be cheaper to auto scale something when there is a peak than have the whole thing scaling at the same time, right? So I mean, most of the time depends, but it gets more, I think it's more pricey to have microservices. And then there is another overhead. So teams start working independently on microservices, right? So imagine that you, Dan, go to create your documents, and then Stephen go to create the reports one. So you start creating and having your own databases because remember, it's a self-contained thing. Sometimes kind of they share databases, but it's not the rule, because what you want to have is teams that have their own CI/CD and their own testing, and they can work independently to release new versions independently of others. You don't want to wait for a change of schema in the database and synchronize that and with the other team if you want to release a new feature, right? That is one of the pros of microservices. But then you start getting different versions of the same microservice. So you start getting version 1 of documents on, oh, I will just rewrite the whole thing and do version 2 and version 3. But then maybe the background check services, you only have version 1. So what I'm saying is that because you want to maintain backward compatibility, you sometimes have more than one container running for the same documents management. And then you can have one container for background checks and just 2 for reports. So it starts getting messy. Another thing is that you need to communicate a lot. So, oh, I will release a new version of documents management, but now your consumer is not going to be the same theme because you are modifying front end and back end. Now the consumer are other teams. So you need to be able to document all of these changes, right? You need to document everything and be able to say, hey, I will release this that day or other day, or have your own cadence. So all of that adds complexity to the process of development and deployment. And I will say that adds also cost, like money. Does that make sense?
Yeah, it makes sense. It makes sense. I remember you were talking about creating replicates. I guess what does a replicate look for a monolith? Is that just like replicating the entire monolith, or like for
Yes.
microservices I can see like different parts being replicated, but for monolith I'm not sure what that looks like.
Yes, so it just means to copy and clone the whole thing. Yes. And you can
Okay.
have different versions too, but it's the whole thing. Yes.
In your
Gotcha.
first example where you had the monolith that you had to run on 2 servers, do you think it would have been cheaper if you split that into microservices and only had to scale your customer portal?
Oh, good question.
Cheaper on hardware, yes. It was not cheaper in resources. So we were like human resources were very constrained. And I think it was very difficult to just hire some more people to manage all of that, like to rewrite certain things. Yeah. But yes, for sure.
If it was already built that way when you came in, it would have been way better though.
Yes, from the beginning, yes.
Yeah.
All right. So yeah, I mean,
Another question in the chat. If you
yeah, sure.
replicate, if you replicate a monolith, how do you ensure the different deployments stay in sync?
Yeah, I mean, what we did at the time, we were just deploying. I mean, our product or deployment was the same. Like it was just one big script or one CI/CD that was deploying the both things to both servers. So, and we have some feature flags. I don't know if you have heard about feature flags, but basically we were like with configuration disabling all modules so people cannot access, because security also was an issue, right? Like if you have a system that is like public on the web portal, you want to disable the other one so they cannot be accessed. So by configuration, we were disabling certain things. So most of that was just configuration, but it was a single CI/CD pipeline. Does that answer the question?
Yeah, kind of. I think, sorry, I guess my question was more with a monolith, if you're trying to scale it, right? And suppose you start throwing more machines at it and you're deploying it on different machines. So now you've got two copies of a database, right? How do
Yes.
you ensure that all stays in sync? Like, which one's your source of truth?
Oh, I see what you mean. So, I mean, that is an anti-pattern, I must say. That's not something that you want to do. So, like, we are trying to solve some technical challenges of an anti-pattern, which I think should not. But I don't know, like at the time, the web portal didn't really have a database because it was just doing quotes and everything. So at the end, whenever the user was ending like the web portal thing, what it did is just send an email with the quote and stuff like that.
Okay, that makes sense. So
Yeah.
it was like stateless in that sense.
Yeah.
There wasn't any like state
Yeah.
that had to be sent or anything like that.
But still, at the time, the technology that was using, it was server-side processing. So it still, I mean, it was not a static thing. Yesterday, I went there to see, and the system is still there, and it looks pretty familiar to what I did. We're talking this about probably 15 years ago.
Wow.
And yeah, so it's still there, and it was a surprise for me because like the wizard and everything, it was the same. So
Wrote such good code. They just
I don't know if they still have most of the code. What I saw is that they use Vue.js now for the front end, so I couldn't actually see what was behind that. But I think most of the code are still there, so it's surprising. Yeah, I mean, if it works, why change it, right? Oh, I remember that we created like a small module to connect to the stock market. And I think the stock market, like the format, how you need to communicate, it was text file, but with a very weird format, probably based on how computers were parsing stuff long time ago. Like you need to have like a protobuf kind of thing. You need to specify the header and stuff like that. And I remember that there was some libraries, but it was libraries, I don't know, in COBOL or Fortran or something like that. So we rewrote everything in PHP. But it is funny because with a microservice that pain, and I did most of that code and it was painful. I think it could have been avoided. So that's a big regret. Anyway, so moving forward, like I saw this a few months or maybe a year ago. So Prime Video started as microservice, like, well, the certain service inside Prime Video. It was microservices. It was Lambda and a lot of AWS thing. And there is an article that just talks about how they went from microservice to a monolith, reducing costs in almost 90%. So I will throw the link there on some, but I mean, it's not all the time microservices is a solution. That I think that's the story. You can save a lot of money by just going to a monolith or even less complexity. But for sure, microservices allows you to go faster and trying different things, especially in big things.
So maybe the monolith has less infrastructure cost, but that's not really like the total cost. And because you have to think about like how long it's taking to get features and how fast your team can move.
Yeah, especially and serverless is expensive. So yeah.
Yeah, and AWS charging way too much money. I agree.
Yes. Ooh, boo, AWS.
I like AWS, have a whole workshop about it, but my wallet doesn't.
No, yeah. No, I mean, you need to be careful with when you are going to the cloud, any cloud, like it can get very expensive. All right, so when to use Monolith and when to use microservices? Again, it depends. Like I like to see this as a nuanced approach, right? Nothing is black or white. So it depends.
Answer interview questions to get to break into tech. It's just any interview question. It depends.
Exactly. Yes.
Okay.
So it depends, and you start with that, and then you gain time to actually think on that. The size and the skills of your team. If you have a small team, I mean, going to microservices is not gonna work. Like you need to have people to manage certain things, like the API gateway and stuff like that. Even imagine the debugging. Imagine when you need to debug something and you have a request, and that request goes through different services that are independently. How do you debug that code, right? You have tracing and you have all this observability and logging and stuff like that. So it's possible, but it adds complexity to the time of develop. And that's the second point, like cost and time of develop. Monoliths are always faster and are always cheaper. So if you want to create a prototype, just go with a monolith. And if you are just starting with a startup, go to a monolith, that's fine. You can later start migrating small parts of that to microservices. If you anticipate growth, like in the first example, right? Like the web portal and the different things, well, maybe you can split your system by user demand, right? So you can have multiple parts. You maybe can have macroservices, not microservices. But you can start splitting your system by user demand. If you already know that different parts of the system are gonna have different demand, then maybe it's a good time to start splitting that. And then application complexity. If you have an application and certain model that is more complex and you are gonna have people dedicated to that, maybe it's a good idea to create a microservice just for that a specific model. Like for example, the model that calculated certain things to the ERP and everything, maybe that can be their own microservice. And so each time that you modify something, you don't impact everything, right? And you have people specialized just in that code. So you can also split your system in that. Those are my 4 recommendations, but of course there are gonna be more if you go to internet and start looking for that. But I think those are one of the most important. Questions there? Cool. All right. So, but if you still want to do microservices and you love to go to microservices, well, there are some recommendations. Avoid going excessive granularity, right? As we in the background check systems, we start going really granular in like the authentication and everything. You don't need to do that. Imagine the authentication, it's I think that's a good example. And I'm not saying that you should do a microservice or not, but imagine you have a database with users, right? With authentication, then you need to start interchanging tokens between the microservices and invalidated tokens. And then you have cache, and then you need to have sessions and all of that. It starts getting pretty complex. If you can avoid that, it's better. If you have a system.
Sorry. What would you recommend? Not just, so like, I like the recommendations for like, if you're actually building an app or you're at work and you're making recommendations to stakeholders, but what about for learning purposes? Is there a good reason to build a monolith or a microservice, a series of connected microservices for learning purposes?
For learning, I think I would love microservices for learn, because there are so many concepts there that force you to learn different things, but also to design in the right way. So remember, you are creating interfaces, and that is like, you know, the solid principles or the dry principles, but applied to your web interface. And that's super nice. You have one service that is just doing one thing, single responsibility principle, right? So I think for learning, I think microservices is better. Yes. Okay, and cool. maybe you can go there to open source projects and start splitting those in microservices. That would be cool. You can also reuse, right? You can reuse code from microservices that you already built in other applications. We don't then need to copy and paste. Of course, libraries also do that, but anyway. if you are migrating from a big monolith to microservices, don't try to migrate everything, right? Start small. So you can, this is another thing that I have seen. So you have a monolith, right? You have this big system. You want to migrate to microservices. One thing that you can do is like fake those in microservices. So you can have different APIs, and they at the end, at the back is just a big monolith, but you are faking you are splitting the system, right? So, or having replicas of the monolith, but just on the front end, you have small APIs. Instead of going to the code on the back to accessing certain module or feature or class or library, you go through the API, you go through the HTTP REST API. And what allows you to do this is that then you can start migrating certain parts. Oh, then I will take this part of the code, I will migrate it as a microservice, and you don't have downtime. I mean, the code is going to be transparent. It's going to be still working. You just switch from a monolith to a microservice and everything is going to be working. So start small, start with small migrations and build the interface first, and then start migrating the code behind of that. If you have multiple teams, communication is clearly like the big thing. Communicate when are you going to release, how are you going to release, document everything. Like between teams, like if you are doing breaking changes, communication is everything. One thing that we have used is TypeSpec for REST APIs. So I don't know if you are familiar with Open API, not OpenAI, Open API, which is like standard to document Swagger to a standard to document REST APIs. But Open API is like really is this big JSON that is convoluted and difficult to document. So there is something that is called TypeSpec. It's from Microsoft, but really it's good. It's really good. It's not. This is not sponsored. So it is a way to document the specification of the REST API in a nice way for developers, and it can compile to an open API. So that's fine. So that's something that I have used in the past, or teams have used in the past to communicate the changes between REST APIs. And then, I mean, fundamentals, right? Control version system, CI/CD, have a way to roll back, do integration tests and everything, because sometimes you need to switch from a microservice version to another one or do certain things. And I mean, all those best practices. Canary release, like CrowdStrike's things, and yeah. All right. Questions here? Cool. So this is the recap, right? So if you are developing, I mean, Monolith is easier for development and deployment. It's better. It's better for testing and debugging. It's easier. That's the word that I'm looking for. It's easier. It's not that complex. Scalability, microservices scale like better than monoliths. Security and management, and I'm talking about security management, not actual security. Like in a monolith, you have a single database, right, of users, and then you don't need to worry about if certain APIs are vulnerable or anything. Microservices, you imagine if you have vulnerability in one in operative system, you need to manage a lot, right? You need to create a lot of operative systems, but also you have multiple APIs, so you have multiple vulnerable points. So you need to manage more security in a microservice. It gets very complex. Flexibility in a microservice is more flexible, how to modify certain things or add features. It requires more specialized skills and development resources. If you are deploying this to Kubernetes, good luck, but you need more, you need to know more things. If you are deploying even to the cloud, you need to know more things to actually do this. It's not simple as having just, I don't know, backend or frontend. Now you need to know about networking and you need to know about protocols and stuff like that. And one thing that maybe I didn't stress enough in the presentation, but it was the failure impact. And I think someone say that or ask a question related to that. So in a monolith, you have a single point of failure. So if the whole thing can get down pretty easily. And a microservices, maybe the report system is not working, but everything else is working, right? I mean, it is not super happy because there are some microservices that gets dependent on others, and you start getting dependencies, and sometimes managing that dependencies is hard. And then you start having microservices that are more core or critical than others. And if they go down, everything go down, and it is more difficult to know what is happening, right? Like, oh, why this thing kind of seems like
I was
works.
going to add observability is a point for Monolith.
Yes, yes. Yeah, for sure.
Just kind of debugging there, but yeah.
Yeah. Something like this.
I
All
can't
right.
be on an observability team and not say.
Yeah, okay. Thank you. All right. So that's pretty much what I have. We can go, I don't think we have time, but we can go to any questions that people have or discussions. Cool. All right.
I can ask you more questions. I wanted to give time just in case anybody else had them. But I'm assuming people are mostly junior devs on the call. But how would you, when you start a new job, how would you kind of get to know figure out what type of systems your company is running, and how would you ask questions surrounding like getting up to speed on your code bases?
Oh, wow. That's a hard question.
It depends.
Yeah, of course it depends, but but there are companies that don't document anything, right? So you just need to discover everything by the code, and you just need to discover everything asking people, tribal knowledge, right? And then there are companies that they really have everything documented. And so I don't know. For me, it's pretty clear to understand what is a microservice and what is not when you go there and try to identify different things. Because if it's not self-contained, then it is a microservice. But at the end of the day, and this is what I'm trying to say here, it doesn't matter really. There is no company that does just microservice and one company that does monolith. You will have a system that is split in different sizes and different things, and you will have different teams working in different things. So, at the end of the day, I think it doesn't matter. What it matters is when you start trying to communicate with another API, and then you need to ask how, and how are you going to deploy that, and how you're going to communicate that with that, and the version and stuff like that. So,
okay, so you would just worry about your team's code bases unless your code bases interact with another team's. Is that kind of how you would approach it?
Yeah, and then if you are junior, you're not gonna there and they want to ask you to own the whole thing, right? You're gonna start with one code base maybe, and then you're gonna start like adding changes and understanding the CI/CD process and everything. So I guess my recommendation would be to be sure what's the impact of what you're doing, right? Who is consuming your system or the part of system that you are doing, and to be able to communicate again, like communication I think is essential when you are working with other teams.
Very cool. There was a hand raised. Does someone want to unmic?
Yeah, I saw on Raul, right?
Oh, yeah. Hey, guys. I was going to ask, why do you think there is so much fear when you have different microservices and each one has a different DB, and you need to duplicate data in each microservice? You are not going to duplicate everything, yeah, but for your current context, you just need some specific data. You don't need the whole data of the common model, whatever. So why do people fear about doing that? I'm just asking, what do you think?
Yeah, that's a good question, and that probably is a whole new presentation, right? So the words that I come with my mind is like the single source of truth, right? You need to define what is your source of truth, and you should have just one when you are talking about data. Because when you are replicating data, what really you have, even if there is not Redis or caching mechanism, it is a cache, right? You have eventual consistency, right? You cannot have like immediate consistency when you have two different parts of the system that are replicating data. So like, yeah, you don't need to be feared to do the normalization But what you need to be very careful is to have a single source of truth to be able to like know what is the right data when you have a problem, right? When you are troubleshooting things. But yeah, no. I mean, when you have a microservice, if you really want to have self-contained, sometimes you just need to replicate the data and have your own database. Also, another thing that I can think is GraphQL. GraphQL kind of like it was invented for just getting the data that you need from one API, right? So it's supposed that you just get one small part of the data when with a query. That's the GraphQL. It's like query language. So you go there and you query what you need and you just get that. Because as you said, when you have big REST APIs and you sometimes get the users, you get all the information about the users. But I mean, there are different techniques to try to solve that. Another thing that you need to be very careful when you have unifying APIs, and by that means one request, but that goes to different microservices to be able to fulfill your request of data to your data request, is that it doesn't get slow, right? Like that you are not really going to do a lot, I mean, of microservices in the back, how the data is closer one from another, how you are combining that data. You want to avoid that a single request, API request goes to different microservices because it can get messy and slow and complex. And yeah, so if you need to replicate the data in one microservice to avoid that, also I think it's a good idea. That's what I can think of right now.
Yeah, thank you. I was just talking about that because on a project we used this pattern called event carried state transfer, which is quite interesting, but it's a bit complex. But by using that, you actually, as you mentioned, you have one source of truth from where we get the data, but you are not listening to a queue, you are not listening to a broker, or you are not doing a direct interaction with the others. I mean, so you just sync your data on your own from time to time, and you have your local copy for what you need. It's a bit complex, but it's different and interesting. So your service can run on its own without the others, completely independent. Yeah.
Cool. Yeah, no, I will check it out. Yeah, thank you for sharing. So I see if it's not broken, don't fix it. Probably AWS was sharing Mesh. Okay, cool. Thank you very much, everyone.
Awesome. Well, thank you so much for the chat. It was great. I learned a lot, and I'm sure everyone else did too. Is there anything that you would like to plug? Any of your own chats or YouTube channel or anything before we go?
No, I mean, people can know where to find me. I mean, if you want to follow me, that's fine. It's like choose your poison. I think I have that. So I do stuff in YouTube, LinkedIn, GitHub, blog, Substack. But if you haven't find me, maybe you don't care. So that's fine. Yeah.
If you like raccoons.
If you like raccoons, follow me. If you like dry humor, also follow me. It's not for everyone. I know.
Sorry, Maho, I have a question.
Yeah, sure.
Yeah, I forgot to ask this. How'd you broke into Microsoft?
How what?
How'd you broke into Microsoft?
So I was working for the background check company, and then my manager, he went to Amazon, and he asked me to apply for Amazon. He was trying to poach me, and then I went to Amazon and applied, but then at the same time I applied to Microsoft, and then I decided to go there. Yeah, after the interview, I think that the people was amazing, was smart, was a nice place, and yeah. So I mean, what I mean about the manager is that he sparked that to actually move to a different company.
But did Amazon accept you as well?
No, I went to the whole interview process at the end, but no, they didn't extend an offer. Yeah.
So the referral does not work at all?
No, I mean, I talked with the hiring manager and everything. I think I failed something. So that, I mean, I failed some of the interviews. I don't know why, but at the end, when I finished that, and then I went to Microsoft, the offer from Microsoft or the answer from Microsoft came before, so I didn't mind at the end. So it was like, yeah, sure. And I didn't apply later. So yeah, I guess I need to apply again. He's
I
now in
see.
Google though, so I mean, I want to work with him, but now he's in another company, so yeah.
I see. One more question. What when you said you were in a startup before, right?
Sorry?
Were you working for a startup before?
Yes, in Mexico, yeah.
Oh, so are you guys like using company laptop?
Company laptop?
Yeah.
Yeah, for sure, yeah. Why the question?
I see. All right. Well,
Jay has
well,
a startup.
yeah, because I'm also building a startup, so I guess I better start buying company laptops now.
Oh, I
Any
see.
recommendation where to buy and where to set up?
Yeah. So yeah, I mean, it was a company laptop, and they have this culture of giving the developers the best tools that were available. So they didn't save money in developer tools. So they really invested on that. They save money in on other things though, so like coffee, but not in developer tools. Yeah.
Well, yeah, they probably shouldn't save on the coffee.
I know. But we were small. We were like we start like probably 3 or 4 developers. We grow up like to probably 10, and then we have explosion of to 20 or 30, and then we went back to 10. And then the company was sold, but one of my friends that was also a software programmer or software developer, a close friend, he bought the system, the loan system, and then that loan system became their own company. So just the software for that loan company, that small bank, it is now an own company, and he still is the CEO. And yeah, so it was cool. It was a cool time. Yeah.
All right, thank you for your input. I mean output.
Yeah, thank you for the question.
All right. Well, thank you again. And thank you everyone for coming. And I will see you guys next week for some live coding if anybody is interested. And yes, that was so great, Maho. Thanks again for joining us.
Thank you for inviting me. Bye.
Thanks, Maho. Thanks, Callie.
Bye, guys.
Bye. Nice to meet you all.